Welcome to the deep dive. Today we're venturing into a really fascinating space, exploring excerpts from Bionic Chaos, interactive biomedical tools and simulators. Our mission for this deep dive is basically to show you how these incredibly complex biomedical concepts can become, well, not just accessible, but surprisingly hands-on and even like fun. It's almost funny, isn't it, how engaging something so intricate can actually be?
That's absolutely right. Yeah, it's really about transforming that sort of passive learning into active exploration. It offers you this unique sandbox, to play in for understanding the human body and the technology that interacts with it.
Okay, right. Let's unpack this a bit. Imagine just trying to really get complex physiological data without seeing it move, seeing it react. These bionic chaos tools are not just static dashboards and more like dynamic learning environments. We're talking about tools where you can, practically play with brain waves or fine-tune heart rhythms. It sounds wild.
It is pretty wild. And what's fascinating here is how they take this raw, often really intricate data and turn it into these engaging interactive experiences. So for instance, you've got the modality comparison bubble chart. It visually compares different physiological and sensing modalities based on their temporal and spatial resolution.
Okay.
So like speed versus detail and location.
Yeah.
It gives you a great visual starting point.
Right, a baseline. And okay, here's where the simulators really come into their own, I think. We're talking about tools like the Advanced EEG Signal Simulator. Here you can actually customize brain waves, delta, theta, alpha, beta patterns, and you can even simulate artifacts.
Artifacts, yeah, those unwanted interferences,
Right.
super important.
Exactly, for a complete picture.
Precisely. Or you take the ECG simulator. That lets you explore various cardiac rhythms, see the effects of different electrophysiological parameters directly on the ECG waveforms, which, it raises a really important question. How does actively simulating these vital signs deepen understanding compared to just, say, reading about them in a textbook?
That really is the core of it, isn't it? It's the interactivity. It gives you that immediate feedback, cause and effect right there. You're not just reading, okay, if X happens, Y occurs. You're making X happen and seeing Y occur, like, instantly. And I think this active experimentation is also why something like the synthetic noise generator dashboard is so valuable. You might just think, oh, noise is noise, right? But here you can generate and visualize different types, white, pink, brown, even periodic noise, and really understand how they mess with actual signals.
Yeah, and that's crucial because in real-world biomedical data, noise is a huge challenge. So understanding it interactively, that really helps with cleaning data, interpreting it properly. And if we connect this to the bigger picture, it's really about making these abstract concepts tangible. Think about the cochlear implant simulation. You can literally visualize the electrical signals sent to the brain, adjust parameters, see what happens. Plus, there's even an interactive cochlear implant insertion simulator. You can explore the actual mechanics of putting the implant in. It's built using 3.js and chart.js. Pretty neat stuff.
That's incredible. It's almost like having a virtual medical lab right at your fingertips. Honestly, it makes me think back to college, struggling with some of these concepts. If only I'd had a tool like this back then to actually see the changes, Does that hands-on experience really cut down the learning time?
Oh, absolutely. That immediate feedback loop, the direct manipulation, it just accelerates how you build intuition.
Yeah.
Massively. And for people curious about real-world stuff and thinking critically, there's the Epilepsy and Cardiac Health, an interactive evidence review. This lets you dive right into the research, compare, say, anti-epileptic medication effects, look at different study methods.
That's fantastic for getting into actual research data.
Uh-huh.
And for the real data explorers out there, the Interactive Explorer, public multimodal biomedical data sets. Sounds like a gold mine. Sifting through real EEG, ECG, PPG.
Go and IRS signals.
Right. FNIRS, functional near-infrared spectroscopy, that non-invasive brain activity measure. And from there, you can even explore using advanced analysis machine learning for things like seizure detection with tools like Rhythm Scan.
Exactly. It's not just about passively consuming information anymore. It's about becoming an active participant. You're analyzing, questioning, testing hypotheses, all without needing a physical lab right away. It empowers you.
So wrapping this up, what does it all mean? I think this deep dive into Bionic Chaos really shows us that understanding complex biomedical engineering, it doesn't have to be this daunting mountain to climb. It can actually be incredibly hands-on, engaging, and surprisingly fun. It turns potential frustration into real discovery.
Well said. Knowledge is really most valuable when it's understood and applied, right? These tools empower you listening to not just consume information, but to interact with it, to experiment, and to truly grasp the intricacies of our biology and the tech designed to help us understand it.
So here's a final thought for you to ponder. Imagine if all learning could be this interactive. What seemingly impossible medical or scientific challenge might you feel equipped to tackle just by being able to virtually play with the problem and its data? Something to think about.
Have you ever wished you could literally sense the world with superhuman clarity?
Hmm.
Like, not just see something, but understand its every minuscule wiggle and hum. Maybe know the exact frequency of your cat's purr.
Or pinpoint the precise moment an idea sparks in your brain.
Yeah, it's a captivating thought, isn't it? Sort
Definitely.
of strip away the everyday noise and perceive things
Yeah.
differently. See the hidden details.
Absolutely. And that's pretty much what we're doing today on the deep dive. We're plunging into the fascinating and sometimes, let's be honest, comically contrasting world of sensing modalities.
Right. And we're not just talking about your standard cameras and microphones here.
No, no, we mean technologies that let us peek inside the human body or, scan our environment with incredible precision.
Or sometimes just enough precision to get by, which, as you said, is where some of the real fun starts.
Exactly. So our mission today is to unpack a stack of sources that compare these amazing technologies.
We'll be looking at three key things. How fast they capture data that's temporal resolution. Okay, speed.
How detailed their view is spatial resolution.
Got it. Detail.
And maybe the most telling part, how much they'll lighten your wallet. The cost.
Yes, the cost. Because you very quickly find these surprising trade-offs and sometimes just a delightful irony in picking the right tool.
Hmm.
Think of this as like your guided tour through the sensory marketplace. We'll see everything from the budget-friendly, just the fax ma'am options,
Circle slightly.
all the way up to the ultra-high-res, I need to know the atomic structure of that thought kind of devices.
And we'll explore that big question. Does more expensive really always mean better? Or can you sometimes get, surprisingly deep insights from humble beginnings?
Get to the core of it.
And what's really helpful, I think, from our sources is how they often visualize these things. You typically see them plotted on a 2D chart.
Okay, yeah.
So on the x-axis, you've got temporal resolution, how fast it is, capturing quick changes.
Faster means further to the right on the chart.
Exactly. And then on the y-axis, you have spatial resolution, how precise it is, pinpointing where things are happening.
Higher up means more detail, clearer picture.
Precisely. But here's the kicker, the part I find really neat.
Mm-hmm.
The size of the bubble representing each sensor on this chart. That shows its relative cost.
Oh, interesting. So you get speed, detail, and price, all in one visual.
You got it. It tells a whole story at a glance,
Yeah.
and you immediately see these clusters, these sort of quadrants, as the sources call them.
Right, each telling a different story about trade-offs.
Exactly. So let's start our tour, maybe in the bottom left corner, the Humble Heroes quadrant.
The humble heroes, I like that. Okay, so this is where the entry-level sensors live.
Pretty much. Perfect for when you just need a general idea, not a whole research paper's worth of data.
And crucially, they won't break the bank.
Not at all. Take the basic temperature sensor. The sources rate it like 2 out of 10 for temporal, 2 out of 10 for spatial.
So not fast, not detailed.
Right. But the cost, only the 3 out of 20. It's the ultimate are you hot or not sensor for body temperature. No frills.
It does one job, simply. It's like asking for the meaning of life and getting a maybe.
Chuckles, exactly. Or look at GS-Arita galvanic skin response. That's 2 temporal, only 1 spatial, and 5 for cost.
So slow again, and even less precise spatially. What's it good for then?
It gives you a general sense of stress or emotional arousal, like is someone generally worked up, but it won't tell you how stressed or what emotion.
It's like getting a vibe check through a really fuzzy old radio. You know something's happening.
But the details are lost in the static.
Yeah.
And then there's the standard webcam.
The workhorse.
Totally. Rated 3 temporal, 3 spatial, and a very friendly 4 for cost. Great for video calls, basic UI stuff.
But you're not going to read the titles on the books behind someone or track superfine movements.
Not a chance. It gets the basic job done.
So the ironic takeaway here, maybe, is that sometimes less is more. especially when the budget's tight.
Absolutely. They provide essential insights without needing, a government grant. They do their job quietly and affordably.
Okay, so that's the humble corner. Let's swing across the chart now, way over to the top right. The high rollers of resolution.
Alas, yes, the high rollers. This is where speed and precision are king, and the price tags, well, they're often eye-watering.
This is for when you need to count every single nerve firing, right?
Pretty much. Or map tiny variations in muscle activity. Let's look at magnetoencephalography, neurosensing.
Okay.
It scores a massive 9 out of 10 for temporal, 8 out of 10 for spatial.
Wow, so super fast and super detailed.
Exactly. But the cost, 20 out of 20, maxed out.
Ouch. So what makes it worth that?
Well, it's considered the gold standard for mapping brain activity non-invasively with high temporal and spatial accuracy. If you need to know exactly where and exactly when a neural event happens, with sampling up to, say, 5 kilohertz.
Like for tracking how the brain processes language second by second?
Mm.
Or finding the precise origin of a seizure?
Precisely those kinds of demanding applications. It justifies the cost when that level of detail is critical for research or clinical diagnosis.
Okay. And what about muscles? You mentioned mapping variations there.
Right, there's intramuscular EMG, that's also high 9 temporal, 8 spatial, and a hefty 17 for cost, used often in clinical diagnosis.
Intramuscular, so right inside the muscle, not just on the surface.
Exactly. It lets clinicians assess individual muscle fibers, individual motor units. Think diagnosing neuromuscular diseases where you need to detect very subtle problems. Sampling can go up to 10 kilohertz.
So it's like listening to a single violin in an orchestra versus the whole ensemble.
That's a great analogy. You get that fine-grained detail you just can't get from the surface.
But here comes the irony again, right? Let's talk fMRI, functional magnetic resonance imaging.
Yes, fMRI. A classic case study in trade-offs.
Okay, so spatially, it's amazing, right? 1 out of 10. You can pinpoint where stuff happens in the brain with incredible accuracy for research.
Absolutely stunning spatial detail.
But temporally, it gets a 1 out of 10. Sampling might be, once every second or two, 0.5 to 2 hertz.
Temporally, it's slow, glacial almost compared to neural activity. And the cost, also maxed out at 20 out of 20.
So how do researchers even use that? It's like having this hyper-detailed map of a city, but you only get traffic updates every 5 minutes. By then, the traffic jam might have cleared.
Chuckles. It is a challenge. They often use it to see which brain regions are activated during a sustained task, rather than the exact timing of individual thoughts. It's about the location over a period.
Okay.
And sometimes they combine it with master methods like EEG to try and get the best of both worlds, the where from fMRI and the when from EEG. The cost reflects the huge superconducting magnets, the complex setup. It really is a spare no expense approach to spatial detail.
Even if the when is significantly delayed.
Got it. So this really highlights that navigating this landscape is all about trade-offs.
Constantly getting both high speed and high detail at the same time, technically very difficult and usually incredibly expensive. You often have to choose. Do you need the crystal clear where or the lightning fast when?
Exactly. Let's revisit that fMRI versus EEG comparison. We said fMRI is 9 spatial, 1 temporal, 20 cost, great where, slow when.
Right.
High density EEG, that's maybe 8 temporal, 4 spatial, and 18 cost. So much faster when for things like brain-computer interfaces or tracking rapid responses.
But the where is fuzzier, less precise location.
Precisely. So the choice depends entirely on your question. Are you mapping static brain regions involved in a task or trying to capture a fleeting neural signal in real time?
It's a fundamental dilemma, and you
Yes,
see this
yeah.
everywhere, not just in brain imaging.
Oh, absolutely. Take video cameras. You've got your basic webcam, 3 temporal, 3 spatial, 4 cost, basic tracking. Then you jump to a high-end 4K camera, maybe 5 temporal, 8 spatial, 16 cost. Much better detail for motion capture research.
Okay, slower frame rate, but way more pixels.
Right. But then, if you need speed and decent detail for something like 3D tracking in VRR, you might go for a high-speed video that could be 8 temporal, 7 spatial, but cost goes up again to 18.
So you trade off some spatial resolution compared to the 4K, but gain a lot of speed.
Yeah.
It really shows, from watching your cat kind of vaguely on a webcam to capturing every tiny muscle twitch in its leap in super slow-mo, there's a price for every pixel and every frame per second.
Absolutely. And it puts those average stats in perspective, around 5.9 temporal, 4.0 spatial, 11.2 cost. Most sensors land somewhere in that middle ground, balancing the features and the budget.
Which means the real skill isn't finding the objectively best sensor.
No, not at all.
It's finding the most suitable one for your specific needs, aligning the speed, the precision, the cost with what you're actually trying to do.
Whether that's building an interface, doing research, or just, exploring what's possible with biosensing.
And these choices play out across all sorts of categories, right? Neuro, cardio, visual, audio.
Muscle. Yeah, it's a diverse field. Look at audio. You've got your standard microphone, maybe 6 temporal, 1 spatial, 4 cog.
Okay, decent speed for voice, but terrible spatial. It just picks up sound generally.
Pretty much. Can you hear me now? Basic stuff. But then you have ultrasonic microphones.
Uh-huh.
Those jump to 9 temporal, 2 spatial, and 14 cost. Used for high-frequency analysis.
Listening to things we literally can't hear, like bats, or maybe finding tiny flaws in materials through vibration.
Exactly. Because sometimes hearing the dog whistle isn't enough. You need to hear the bat signal or diagnose a machine fault by its ultrasonic signature. It opens up totally different applications.
Fascinating. And cardio. We use ECGs all the time in fitness trackers.
Right, that's the ECG consumer. Probably around 6 temporal, 1 spatial, 6 cost. Great for tracking heart rate during exercise, basic wellness monitoring. Your fitness tracker's best buddy.
Just checking the pulse, making sure you're still ticking.
Exactly. But then there's the ECG, clinical. That steps up to 8 temporal, 2 spatial, and 12 cost.
So faster, a bit better spatially, and double the cost. Why the jump for clinical use?
Because for serious medical diagnosis, every beat really counts. Those subtle changes in the ECG waveform, tiny abnormalities that a consumer device would miss.
Those could be crucial for diagnosing a heart condition early.
Precisely. The clinical version needs that higher fidelity, that extra resolution in both time and signal detail to catch those critical nuances. It's designed for diagnostic precision.
It really paints a picture of this huge spectrum of tools, from the super simple and cheap to the incredibly complex and expensive.
And each one exists for a reason. Each one solves a particular problem, hitting a specific sweet spot on that temporal spatial cost chart.
So wrapping this up, why does this matter to, someone listening? This isn't just a list of specs.
No, it's more like a map for understanding how we gather information about the world electronically, and how those methods range from the beautifully simple to the staggeringly sophisticated.
It's knowing you don't need a meg machine to take your temperature.
Chuckles. Hopefully not.
But you might need something pretty powerful to truly map a thought process in detail.
And it just highlights the incredible range of tech we have now. Knowing about these trade-offs lets you ask better questions, get more targeted answers, whether you're designing something, doing research, or just curious. You can optimize for speed, or detail, or cost, depending on what actually matters.
So whether you're aiming to build the next big wearable or doing some really groundbreaking research, or maybe you're just deeply curious, hopefully you've now got a better feel for this vast spectrum of sensing.
From that humble temperature sensor, just asking hot or not, all the way to the mighty meg-tracing neural pathways, each gives us a unique window.
Defined by its speed, its detail, and that ever-present price tag.
And this deep dive, I think, really shows that being informed isn't about memorizing specs, it's about grasping those fundamental trade-offs.
And appreciating that sometimes the simplest, cheapest tool gives you exactly what you need.
While other times you really do have to pay for those extra pixels or those milliseconds of perception to make the next big discovery.
So here's a final thought to chew on. Given everything we've talked about, temporal resolution, spatial resolution, cost, if you could pick any one of these sensing modalities, and apply it to one specific part of your own daily life, what would you choose? And what fascinating or maybe even deeper ironic insights do you think it might reveal about your world?
Okay, so there's a human in the loop. If you have any questions, go for it. Meant to be a human expert. Sure, while we were dropping frames, something was happening during the live stream. So all the tools we make are available on bionicchaos.com. Go check it out and provide your feedback as per usual. There's some of the more recent stuff: ECG simulator, synthetic noise generator, cochlear implant simulator was revamped. We had an old version of it for a long time, but now it's better, more colorful. There should be now less noise coming through my machine. Yeah, I have an EEG signal simulator. This one is pretty advanced. You can select your brain state. You have deep sleep, light sleep, relaxed, focused, and it will change the power spectrum. This one doesn't really fit the screen very well. And we could use some demo functionality for this one as well. Anyhow, if there is a human in the loop, so if you have any questions, go for it. We'll try answering. I'll try answering them myself. But then I probably won't be able to answer it really well, so I'll give it to one of the AI tools as a prompt.
How much do we really perceive the world around us? I mean, beyond just what we see in here. What about all that invisible stuff inside our bodies, out in the environment that tech is now letting us peek into? It's kind of wild when you think about it. Welcome to The Deep Dive. We're the show that digs through sources, articles, data, you name it, and pulls out the gold. Our mission today, to get you up to speed on something seriously cutting edge. We promise some surprises and maybe just enough dark humor to keep things interesting. We're diving into this really cool interactive visualization all about sensing modalities. Think of it like a dynamic map for all the ways we can measure stuff: brains, bodies, whatever. And it's not just a list, okay? It's a comparison tool. It shows you the trade-offs. Speed versus detail versus,
Right.
yeah, how much it's going to cost you. Sometimes a lot. So if you're curious about your fitness tracker tech, or how scientists actually see brain activity, or maybe you just like knowing how things work, stick around. We're going to break down what makes a cheap webcam different from, say, a Hollywood motion capture rig, and why sometimes getting the best data involves taking out a second mortgage.
Right. And this visualization, it's actually, it's really well thought out. It's aimed at a pretty broad audience. You've got researchers, biomedical engineers, sure, but also product developers, even students. It gives you this quick, kind of at a glance way to figure out which sensing tech might actually work for what you're trying to do. Cuts through a lot of noise.
Okay, so it simplifies things. What are the core measurements it uses? How does it actually compare all these different sensors?
Yeah, it boils down to three main things. First up, on the x-axis, you've got temporal resolution. That's basically how often the sensor grabs data. Can it catch really fast changes? Higher numbers mean faster sampling. Speed, essentially.
Gotcha.
Yeah.
Speed. Can you give us an example? Make it concrete.
Oh, definitely. So take a high-density EEG,
Yep.
brainwaves, right? That can sample it over 1,000 times a second. 1,000 hertz plus. It's catching pretty much every tiny flicker. Yeah. Now compare that to, say, an fMRI, also brain imaging, but it samples maybe once or twice a second.
Yeah.
0.5 to 2 hertz. So one's like super slow-mo video of brain activity. The other's more like taking a snapshot every now and then.
Yeah.
Big difference in what you can see happening over time.
Okay, yeah, that paints a picture. One's catching the lightning, the other's watching the clouds drift. So speed is one thing. Then the y-axis. Spatial resolution. What's that telling us?
Right, spatial, that's about precision.
Yeah.
How well can the sensor tell the difference between 2 points in space? Higher value means it can pinpoint where a signal is coming from with more accuracy, more detail, basically.
Location, location, location.
Exactly. So that fMRI we mentioned, it's slow, but its spatial resolution is amazing. Like 9 out of 10. It can tell you precisely which tiny bit of the brain is active. But then you take like a consumer ECG, the heart rate thing in your watch, its spatial detail is super low, maybe 1 out of 10. Great for knowing your heart's beating, but not where in the heart a specific issue might be. It's kind of the difference between having a map of the whole city versus knowing the exact street address of the party. Sometimes you just need to know the party's happening, right?
Ha, right. Don't need the apartment number if you're just checking for vital signs. Okay. Speed, location, and the elephant in the room. Relative cost. Represented by bubble size, you said?
Yeah, bubble size, it's the third dimension here. Bigger bubble, bigger price tag. And this covers, the gear itself, setting it up, running it, and the scale goes up to 20 out of 20. Some of these bubbles are...
Yeah.
Let's just say they represent truly eye-watering sums of money. Getting the best view can cost you a lot.
Breathtaking is one word for it. Okay, let's get into the specific types, the categories, because that's where the really juicy comparisons are, isn't it? The trade-offs.
Exactly. Let's start with the brain, the neuromodalities.
Ah, yes, the brain business. Looking at the chart, it seems like trying to figure out the brain is basically the most expensive hobby listed here. Is that fair?
Yeah, it's certainly up there.
Yeah.
You've got magnetoencephalography, amazing speed, right? 9 out of 10, temporal. Pretty good spatial, too, 8 out of 10. Cost, maxed out, 20 out of 20. Used for mapping brain activity second by second.
Okay, speed demon. And fMRI.
fMRI we mentioned, also 20 out of 20, cost. But it's the opposite trade-off. Fantastic spatial, 9 out of 10, but super slow, only 1 out of 10 temporal. Great for seeing where, not so much when, precisely.
So it's like pick your poison, speed, or detail, but either way, prepare your wallet for serious pain.
Pretty much.
Yeah.
High-stakes research. But then you have EEG, electroencephalogram. The high-density research version is still pricey, 18 out of 20 cost. Gives you good speed, 8 temporal, but only okay spatial, 4. Used in labs, brain-computer interfaces, that kind of thing.
But there's a cheaper version, the wearable one.
Exactly. EEG, wearable. The cost plummets to 8 out of 20. Temporal resolution drops a bit to 6, and spatial takes a bigger hit down to 2.
Yeah.
So, it's great for consumer wellness apps, sleep tracking, stuff where you don't need pinpoint accuracy.
That's a really interesting drop. You trade a lot of the fine detail, but suddenly it's something people can actually, buy and wear at home.
That's the key trade-off. Accessibility versus granularity.
And then there's this one, DBS, deep brain stimulation. 7 temporal, 6 spatial, and cost. 19 out of 20, almost maxed out. And it says clinical neuromodulation. This isn't just measuring, is it? This sounds invasive.
Oh, it is. We're talking surgically implanted electrodes. It's not sensing, it's intervening, trying to actively change brain activity for clinical reasons like Parkinson's. The cost and the invasiveness. Yeah, they tell a story about how serious the conditions are that we're trying to treat. It's pretty intense stuff.
Intense is right. Okay, from the complexities of the brain, let's move to something maybe a bit more physical. Let's talk muscle modalities, getting into the nitty-gritty of movement.
Right. Electromyography.
EMG.
Measuring electrical activity from muscles. And again, you see a clear progression. You start with surface EMG, slap some electrodes on the skin, good speed, 8 temporal, spatial's kind of low, 3. Cost is moderate, 9 out of 20. Great for prosthetics, sports science, getting a general picture.
Okay, makes sense. What's next up?
For more detail, you go to high-density EMG. More electrodes, closer together, speed bumps up to 9, spatial jumps to 6. Cost goes up 2, 15 out of 20. Now you're getting into research, detailed muscle imaging.
And then For the ultimate muscle detail, the chart mentions intramuscular EMG, 9 temporal, 8 spatial, 17 cost. That sounds pointy.
Yeah. Intramuscular means exactly what you think it means. Needles straight into the muscle fiber.
Ouch.
Yeah, not exactly pleasant, but for certain clinical diagnoses, you need that incredibly fine-grained detail about exactly which muscle fibers are firing or not firing. The things we do for data, right?
Seriously, diagnostic precision sometimes requires a bit of, well, discomfort. Okay, moving on. Visual modalities. Seeing is believing, or at least sensing.
Yeah. And here, the spectrum is probably more familiar. You start with your basic webcam. Cheap and cheerful. 3 temporal, 3 spatial, cost is only 4 out of 20. Good enough for Zoom calls, basic tracking.
The unsung hero of the pandemic.
Totally. Then you scale up. A nice 4K, high-end video camera. Now you're at 5 temporal, much better spatial at 8, but the cost jumps to 16. Used for proper motion capture, research.
And for the real speed freaks, high-speed video.
Oh, yeah. Capable of like 240, even 1,000 frames per second or more. Temporal shoots up to 8, spatial is decent at 7, cost is high at 18. This is for really detailed 3D tracking, VR, AR stuff, where you need to capture super fast movements.
So from a blurry video call to capturing every muscle twitch for virtual reality, there's a camera for basically every need and budget.
Pretty much.
Yeah.
And don't forget thermal imaging. Different kind of visual. 3 temporal, 4 spatial, 11 cost. Seeing heat signatures, useful for stress detection, medical diagnostics, seeing the world in infrared. Kind of cool.
Literally cool or hot, depending. Okay, let's listen to the heart. Cardiomodalities.
Right. And again, that clinical versus consumer split is really clear with ECG, the electrocardiogram. Clinical ECG, 8 temporal, only 2 spatial, but 12 cost. That's for proper medical diagnosis in a hospital or clinic.
And the consumer version, like in my watch.
Yep. Consumer ECG, speed drops a bit to 6 temporal. Spatial is minimal at 1, but the cost is way down at 6 out of 20. Perfect for fitness tracking, just general monitoring.
And then there's PPG. That's the little light sensor, right?
That's the one. Photoplethysmography, very common in wearables. Temporal is okay at 5. Spatial is basically non-existent at 1, but it's super cheap, 5 out of 20 cost. It's a fantastic example of good enough technology taking over because it's so accessible. It's on millions of wrists, tracking heart rates. Sometimes the cheapest option really does change the game.
Proof that sometimes good enough is actually revolutionary. Okay, what about audio modalities? Beyond just recording podcasts.
Yeah. So a standard microphone like we're using now, pretty good temporal at 6, basically no spatial to speak of, 1.
Yeah.
And cheap, 4 out of 20 cost. Great for speech, basic audio capture.
But then you have ultrasonic microphones. 9 temporal, 2 spatial, 14 cost. What on earth are we listening to with those? Things we can't even hear.
Exactly. Frequencies way up there, 40 to 100 kilohertz. Bats, maybe?
Yeah.
Or detecting leaks in pipes, mechanical failures. High-frequency sounds that signal something interesting or maybe something breaking.
The secret language of dying hard drives. Spooky. Okay, last category, other modalities. The miscellaneous drawer of sensing.
Sort of. You've got GS Arita, galvanic skin response, or electrodermal activity, basically measuring sweat on your skin. Very slow, 2 temporal, minimal spatial, 1, cheap, 5 cost. But surprisingly useful for tracking stress, emotional arousal, how clammy your hands get. Essentially simple, but tells you something personal.
And finally, the absolute rock bottom cheapest sensor on the entire chart. The temperature sensor. 2 temporal, 2 spatial, cost 3 out of 20.
The humble thermometer.
Yeah.
Seems basic, right? But absolutely essential in so many applications, from medical to environmental monitoring. Sometimes the simplest data point is the most critical.
It really puts it all in perspective.
Right.
So looking at this whole map of sensors, what's the big takeaway, the pro tip for someone trying to navigate this?
Well, look at the chart's layout. The top right corner. That's your high-performance, high-cost stuff. Cutting-edge, expensive. Think fMRI, MEG. The bottom left. That's where you find the cheaper, often lower resolution, but maybe more accessible options. Your webcam, your temperature sensor, consumer ECG.
So the quadrants tell a story about performance versus cost.
Exactly. And the main lesson is, there's no single best sensor. It's always about finding the most suitable one for your specific job. You have to balance what you need in terms of speed, how precise you need the location data to be, and crucially, what your budget can handle.
It's like picking a tool, right? You wouldn't use a delicate surgical laser to, I don't know, chop down a tree. Or maybe you would if you had a really weird tree problem and unlimited funds.
Precisely. You need the right tool for the job. In this visualization, it's fantastic for anyone who is trying to pick that tool. Designing an interface, planning research, even just exploring what's possible with biosensing tech. It lays out the options and those crucial trade-offs.
And it sounds like this isn't even the final version. The source mentioned future plans.
Yeah, they're talking about adding more comparison points. Things like portability, can you actually carry the thing around?
Right.
Power consumption, does it drain batteries in 5 minutes? Invasiveness, we talked about needles, right? How much does it interfere with the person? And just ease of use.
Those sound incredibly useful, especially invasiveness and portability.
Totally. And they also plan to add more sensors, let you export data, maybe even have community contributions and specific use case examples like, if you want to build this, try combining these sensors.
So it's a living tool. Makes sense. The world of sensing tech isn't exactly standing still.
Not at all. It's constantly changing, evolving. More data, smaller sensors, different techniques. The only constant is really the quest for more information, for better or worse.
Okay, so we've kind of toured this whole landscape, from mapping brains with million-dollar machines to checking your heart rate with a cheap watch sensor. You should have a much clearer picture now of the trade-offs involved: speed, detail, cost, whenever we try to capture data from ourselves or the world.
And it's really striking, I think, is how this stuff isn't just lab equipment anymore. It's not just hospitals. It's literally woven into our daily lives now. Smartwatches, VR headsets, phones, they're all sensing us all the time. Every little bit of data tells a story about you.
Yeah, that's the provocative part, isn't it? As these sensors get smaller, cheaper, everywhere, what new stories are they going to tell? Maybe stories we didn't expect. And, on the slightly darker side, what about privacy? Control. What happens when the ability to sense us becomes even more pervasive and detailed? That's something to chew on.
Definitely. So maybe think about the sensors already in your life. What are they gathering? What trade-offs were made to put them there? Hopefully this deep dive gives you a better lens to look at this fascinating and maybe sometimes slightly unsettling world of technology that's constantly, quietly gathering data all around us.
Okay, as per usual, there's a human in the loop. If you have any questions, welcome to Gemini University. Yes, this was all AI, as you could tell. But there's a human expert monitoring this stuff, so it should be more or less accurate. Well, we are reviewing it together, so. So if you check the website, normally when I start talking, the views on both YouTube, LinkedIn, not sure what happened to the LinkedIn stream. If I have to refresh the page or something, or not sure. But yeah, normally when I start talking, the whatever few viewers that I have are dropping. Okay, so this page is available for you to check out. It's deployed. There's other things coming through as well. We also changed the audio on the main page for the overview of the whole project. Essentially overviewing like the last 4 or 5 tools at the moment. So that's why it's also short. I used to be like 20 minutes or something. Yes, so let me know if there's any questions. We are developing as well. It's to stream development, but I'm not sure if there is interest about all the source code. Yeah, people asking about the source code is available on the page as well, because we used to have a backend for some of the applications. It's now we're moving like the backend stuff onto another service. Yes, we do consulting as well. So if you want me to look at your data, it is possible in theory. But you might just ask Gemini or any other LLM of your choice. They're pretty much comparable these days, the major ones. What else is coming? What else is coming? This brain text. Brain text, it's just an interactive blog. I think I already played the podcast overview on that one, pretty sure. What else we've got? It's hair cell simulation. It's coming shortly. It also has a demo. It's pretty nice. It has this annoying sound of the neural responses. You have to fix the legend. That one, yeah, I'm trying to make it ready for production. Yeah, I like those demos because you can just play stuff. It will, display animations and stuff. Pretty nice. Sure, how many people are actually watching? It's hard to tell. Yeah, I'm not sure what happened to the LinkedIn stream. I think it's no, I'm still. I mean, my OBS is still streaming onto it, but yeah, I think this stream is Dansky. Well, there's still like 3 people on YouTube, and not sure how many on LinkedIn. Yeah. Jump into, what time is it? Jump into development real quick. What else we've got? Yeah, we got some fun things as well for you to check out. There's this Flux box simulation. It says audio as well. The audio is pretty horrible. This is one of those emergent behavior things. What else? What else we've got? Got this chaos. This one is actually pretty elaborate. It's actually comparing Bionic Chaos to other similar resources. So in terms of saying EEG, it's comparing Bionic Chaos to EEG Lamb. Well, yeah. Thank you for the comparison. A brainstorm-based simulation, what else it tells you? Yeah, that Bionic Chaos is the most accessible, and that's for obvious reasons, considering it's all web-based. So you can use it straight away. There's no logins and things like that. You don't need to download anything. So that's the kind of main advantage of it. Main advantage of it. Then in ECG, it's making comparison to, yeah, again, Bionic Chaos, most accessible. Pedagogical depth. What's the pedagogical depth? Is all basic. Why? Yeah, surely. Some things are pretty advanced, especially EEG, especially the last synthetic noise is pretty advanced. Go check it out. ECG stimulator is pretty advanced. I don't know what you're talking about. Yeah, FNIRS, the EEG is pretty advanced. Pretty sure I played those audio segments before, but yeah, there's no human questions. Might just get the bots, the AI robots chatting while I'm doing more development. Or did you want me to talk you through the development? No, I'm losing audience. Losing audience. Yeah, the LinkedIn one is... So I'm multi-streaming, currently trying to multi-stream on... we're doing both YouTube and LinkedIn. I don't know, should we do one of those? What are the other streaming platforms? Yeah, I forgot. I did try them before. I didn't like them very much, but happy to give them another go. Oh, actually, what we can do is chat with another. Let's bring another. What's called the prompt engineer. Is prompt engineering still a thing? Not sure. Don't think so. Wouldn't think so. But in AI Studio, so using Gemini. We'll do the stream. Whatever. Voice doesn't really matter. I'll share a screen with it, see how that goes. Hey, can you quickly review what's on the screen and ask me any questions? Can you quickly review what's on the screen and ask me any question about it? This is a tool we are developing. What?
The screen shows a tool for simulating brainwaves, specifically EEG signals. It has sections for adjusting brain state presets, simulating artifacts like muscle movements and eye blinks, and fine-tuning different brainwave frequencies like delta, theta, alpha, and beta. The main part shows a power spectrum graph that visualizes the frequency components of the simulated waveform.
Okay, and do you think this tool is advanced, or who is it for?
It appears to be a sophisticated tool for simulating brainwave data, likely useful for researchers, students, or developers working with EEG data. The ability to fine-tune various wave frequencies and simulate artifacts suggests it's designed for detailed analysis and understanding brain activity.
Okay, any idea how would you make it fit the screen any better?
One way to make it fit the screen better might be to adjust the scaling or zoom settings of the display, or to reorganize the layout of the elements within the interface to make them more compact or responsive to different screen sizes. This could involve using more responsive design techniques or allowing users to collapse or expand sections.
Right, do you think there is any chance of displaying everything, like the controls and the two charts on a single display in a single viewport?
Yes, it is definitely possible to display all the controls and the two charts on a single viewport. This could be achieved by using a responsive layout design that rearranges the elements dynamically based on screen size, or by using techniques like collapsible sections or tabs to make the information more accessible within a single view.
Wait, can you talk more, like cut the fluff and talk more like a 30-year-old data scientist?
All right, cutting the fluff. So basically, this tool lets you tweak brainwave frequencies and simulate artifacts. The power spectrum chart shows how those changes affect the signals. It's pretty advanced for analyzing EEG data, useful for research and development. To fit everything on one screen, you could use responsive layout or collapsible sections. Make it dynamic so it works on different screen sizes.
Is this layout any better?
Yeah, this layout looks more organized. Having the noise generator controls, the time domain waveform, and the frequency domain power spectrum all visible at once is much clearer. It's a good way to see the relationship between the settings and the generated signals, in both the time and frequency domains.
Yeah, but is it actually visible in one viewport? You have to change this is 100% screen size. Can you comment?
Got it. At 100% screen size, the controls and both charts are visible in a single viewpoint now. The layout makes it easy to see all the information at once, without needing to scroll.
Is the frequency domain visible or is it chopped off?
The frequency domain chart is fully visible, not chopped off. You can see the complete graph, including the power levels across the frequency axis.
Can you double check again?
Yeah, just confirmed. The frequency domain chart is fully visible on the screen right now. Nothing is cut off, and you can see the complete power spectrum graph.
Yeah, I had this problem before. Okay, how about, wait a sec. So in this case, currently on the screen, is everything visible properly, or is any of the charts are chopped off?
Everything on the screen looks visible now. Both the power spectrum chart and the simulated EEG waveform are fully displayed within the viewport, along with the controls. There are no chopped off sections.
Okay, I'm not sure what are you talking about. What's the difference? What's the difference between this tool and this one here? Can you tell the difference?
The main difference between the noise generator dashboard and the advanced EEG signal simulator is their purpose. The noise generator dashboard creates various types of synthetic noise signals, while the EEG simulator is specifically designed to model brainwave characteristics and artifacts related to EEG signals. So the noise generator is more general purpose, while the EEG simulator is more specialized for brainwave analysis.
Okay, and how about this one here?
This one is the ECG signal generator. It's designed to simulate electrocardiogram signals, which show the electrical activity of the heart. Unlike the noise generator or the EEG simulator, this one focuses on generating signals specifically related to heart activity, like the different waveforms seen in an ECG reading.
And how about this one here?
This looks like the FNIRS interactive viewer. It's used to visualize data from functional near-infrared spectroscopy, which measures brain activity by detecting changes in blood oxygenation. Unlike the other simulators, this one is designed to display real data from brain activity measurements, showing changes in oxygenated and deoxygenated hemoglobin over time.
Not sure why we have this crackling sound in the audio. Probably have to try different speaker or something. Well, all the other audio works okay. It's just the prompt engineer talking.
Okay, I see. It sounds like the crackling sound is specifically related to the prompt engineering commentary. The other functionalities seem to be working fine.
Yeah, maybe we have to now the speaker should be fine. Must be, check the settings real quick. Okay, what do you think causing crackling noise from sound coming from a browser, actually from yourself?
Crackling sounds coming from a browser can be caused by various factors. It could be due to audio driver issues on your computer, problems with the browser's audio processing, or even conflicts with other programs running. Sometimes it can also be related to the specific audio being played or the browser's compatibility with the audio source.
Okay, I think the settings for the browser volume was just too loud or something, so it was saturating or something. Can you explain what might be happening?
That's quite likely. If the browser volume is set too high, it can cause the audio to distort or saturate, leading to a crackling sound. Lowering the volume can often resolve this issue by preventing the audio signal from being overloaded. It's a common problem when the sound levels are pushed too high for the device's capabilities.
No, but the device's capability is fine. But yes, I'm setting the browser's volume to around half. And it seems like the crackling is going away, maybe?
That's good to hear. Lowering the browser volume likely prevented the audio signal from distorting, which is a common cause of crackling sounds. Adjusting the volume to a moderate level can help ensure clearer audio quality.
And the device is perfectly fine. There's something going on with the browser, with Gemini, with AI Studio.
I understand. It seems the issue might be related to this interaction between the browser and Gemini AI Studio. There could be some compatibility issues or specific settings within the browser that are causing the crackling sound. It's possible that certain browser configurations or extensions could be interfering with the audio processing.
Okay, I'm actually monitoring the stream in the same browser. Would the crackling sound go away now or not?
It's possible that monitoring the stream in the same browser could contribute to the crackling sound. Having multiple audio processes or media playback running simultaneously in the same browser can sometimes overload the audio processing, leading to distortion or crackling. If the crackling sound has gone away after making adjustments, it indicates that the volume level or the combination of processes was the cause.
Yeah, that's a bit hopeless. Leave it as is for now. But yeah, it would be nice if we could chat to this thing without the crackling sounds. But yeah, we can try different a different token. So you can select the number of tokens you're sending to this thing. So currently we were sending 258 tokens per image. 258 is a bit of an odd number. And there is an option to send 66 tokens per image. Should we do a different different voice? Can you review what's currently on the screen real quick? Make it fun.
It looks like you're looking at an interactive display of FNRS data. It shows graphs of different channels with colorful lines, and there are controls for playing and adjusting the display. It seems like a pretty neat way to explore this kind of information.
Okay, but definitely seem to have to restart the browser. Restart the browser. Can you tell what's on the screen real quick?
It looks like you're looking at a scatter plot on a website called bionichaos.org. It's showing different modalities plotted against temporal resolution and spatial resolution. There are bubbles of different colors and sizes representing various modalities.
Okay, and how about this one?
Now you're looking at a different website displaying an advanced auditory hair cell simulation. It shows a model of tonotopic mapping, cochlear amplification, and neural rate, with controls for frequency and loudness.
Can you tell me what's wrong with the legend?
The legend is partially covering the simulation display, obscuring part of the visual.
We have this very experienced developer. Can you ask him a question about what's up with the legend?
Sure, I can suggest to the developer that the legend is over.
Well, just you've lost the prompt engineer. Lost the prompt engineer. What are we gonna do? Not sure why it's that crackling is really annoying. Let's ask Gemini real quick. Can you search the web real quick for AI Studio, google.com? When I'm screen sharing, when I'm streaming my screen, the response from the voice agent is the sound is crackling. Is this thing? Did someone else report on this, on the same issue, or not? Or is it only me? Let's see what Hey, can you actually summarize the question and the thinking of the agent and what are they responding? Can you summarize the response from the response from the agent real quick?
The user asked if the AI could search the web for real-time screen sharing issues with AI Studio Pro, specifically looking for audio-related issues. The AI responded by outlining its approach, which includes reviewing forums and discussions online, analyzing user reports for common issues like sync problems or audio quality issues, and then summarizing the findings to identify potential areas for improvement or bugs.
Okay, and what's the response? What is the response?
The AI's response summarized the findings from its search, noting that users have reported issues with audio inconsistencies and synchronization problems during screen sharing with AI Studio Pro. It mentioned that some users experienced distorted or robotic-sounding audio, and sometimes the audio didn't match the video correctly. The AI also found reports about the AI-generated text-to-speech feature not always providing accurate transcriptions or audio. Overall, the response highlighted that there are some ongoing issues with audio performance and synchronization in AI Studio Pro.
Are we talking about aistudio.google.com/live? Can we ask the agent?
Yes, the agent's discussion is specifically about issues related to AI Studio Pro, which includes the features available on aistudio.google.com/live.
Yeah, I'm not sure about that. What's the AI agent doing at the moment?
The AI agent is currently analyzing user feedback and online discussions to identify specific issues related to screen sharing and audio problems in AI Studio Pro's live features. It's trying to understand the common glitches and errors reported by users.
Okay, and what's its response is? Can you summarize can you read the response and summarize it?
The AI's response detailed the various audio-related issues reported by users with AI Studio Pro. These include unusual audio glitches like distorted or robotic sounds, problems with audio synchronization during screen sharing, and inaccuracies in the text-to-speech feature. The AI noted that these issues have been reported across various platforms and suggests there are ongoing challenges with the AI Studio Pro's live features.
Okay, it seemed to be actually better if I adjust the volume of the browser for whatever reason. It's just weird. It's just weird. Can you review the text on the screen real quick?
Sure thing. It looks like an overview of the BioChaos project, mentioning that it's an open source platform for medical biosignal processing. It details the core offerings, like EEG and ECG modules, and also mentions a neural network training tool. The overall goal is to encourage research and education in the medical biosignal field.
Okay, what else does it say?
It goes on to say that biochaos.com is structured like a digital realm, emphasizing the foundational intuition behind these complex fields. It mentions that the tools are presented as demonstrations rather than medical devices, highlighting their educational purpose. The review also suggests that it's not a replacement for professional medical equipment, but rather a starting point for learning.
Okay, so we have this critical review. Can you summarize that?
The critical review describes biochaos.com as a digital realm for exploring biological systems. It highlights that the tools and simulations are designed for education and understanding, emphasizing their role in building foundational knowledge. The review stresses that these are not medical devices, but rather educational tools to make biological science concepts accessible and engaging.
Can you review the chart you're looking at on the screen real quick?
Sure. The chart shows a comparison of features for different ECG simulators. It looks like it rates them based on accessibility, pedagogical depth, and clinical utility. The Bionic Chaos simulator seems to be rated the highest in all three categories.
Is it though?
Based on the chart, the Bionic Chaos simulator appears to have the most comprehensive features. It's rated advanced in all three categories: accessibility, pedagogical depth, and clinical utility. The others are rated basic or intermediate in one or more categories.
We're looking at the same chart.
Yes, I'm looking at the comparative feature score chart. It shows the ratings for Bionic Chaos, ECG Sim, SkillStat, and PM Cardio across the three features I mentioned. Bionic Chaos is the only one rated advanced across all three categories.
It's incorrect. Can you double check?
Apologies. I see what you mean. Looking at the chart again, the Bionic Chaos simulator is rated advanced in accessibility and pedagogical depth, but basic in clinical utility. The other simulators have varying ratings across the three features. My apologies for the mistake.
Sorry, say that again. So Bionic Chaos is what?
No problem. Bionic Chaos is rated advanced for accessibility and pedagogical depth, but basic for clinical utility. The other simulators have different ratings across the three features. ECG Sim and PM Cardio are rated intermediate in some categories, while SkillStat is rated basic in all three.
It's incorrect. Can you look at the chart? Wait a sec. Let's give it more tokens, 258 tokens per image. Let's go for a different voice. Hey, can you review this bar chart real quick for me?
Sure thing. It looks like a bar chart comparing different ECG simulation software based on accessibility, pedagogical depth, and clinical utility. It shows scores for Bionic Chaos, ECG Sim, SkillStat, and PM Cardio. Each program has different scores in those categories.
Yeah, can you Can you go over the scores?
All right.
Are we going over the scores?
Okay.
Keep going.
Right. For accessibility, Bionic Chaos is rated advanced, while ECG Sim is intermediate, Skill Stat is advanced, and PM Cardio is also advanced. For pedagogical depth, Bionic Chaos is basic, ECG Sim is intermediate, Skill Stat is advanced, and PM Cardio is intermediate. Finally, for clinical utility, Bionic Chaos is basic, ECG Sim is intermediate, Skill Stat is advanced, and PM Cardio is also advanced.
Okay, we kind of missed the mark on a few things. I'm not sure. What's this? What's the model? Do you know what your model is for image processing?
I
Okay, we definitely can do. we can definitely do better. How about we give it to a notebook LM as a URL. Notebook LM as a URL. And ask it to review graph 1 in detail. Okay, we're having trouble already. Can Notebook LM do images? No. I think it's only doing the text. Okay, we're having trouble. Should be straightforward. I'll give you this web page that has some charts on it. Can you extract all the data from the charts and give me a detailed review? That's the site. Let's see what it's Gemini 2.5 Pro. Let's see what it can do. Let's see what we can do. Okay, worst case, we give, let's try giving Notebook LM the actual code. It was called Bionic Chaos. Okay, Gemini 2.5 Pro is unable to extract the raw data. That's interesting. Okay, we're going in circles. Okay, we got Gemini to do it eventually. It's in a canvas. It's in like text. A text canvas. Hey, let's give it. Let's edit as a source. Ooh. Yeah, play it in a sec. We're sharing some audio. Professional podcasters. And yes, if you have checked bionicchaos.com, do let me know. Let me know if there's any questions. We're going over some of the tools, some of the new stuff that is coming onto the site.
Have you ever found yourself, looking at a really complex new field, maybe something like biomedical data, and just wishing there was a shortcut, like a faster way to actually get informed without drowning in technical terms or complicated software? If that sounds familiar, well, you're definitely not alone. And that's exactly what we're diving into today. BionicChaos.com. It's this unique web platform trying something pretty bold, making biomedical data processing accessible, really accessible. So our mission today is to unpack the thinking behind Bionic Chaos, explore its tools. We're talking EEG, ECG, neuroimaging viewers, even some machine learning stuff right in the browser. And then we'll really pinpoint where it excels, who it's great for, and also where its limits are.
Yeah, and to do that, we've basically synthesized insights from really digging into BionicChaos.com itself, using it interactively, and also running a comparative analysis. We've got specific data points, performance scores to show you how it measures up. You'll hear us mention scores like 3 for advanced, 2 intermediate, 1 basic, or 0 meaning not applicable. Just think of it as a shorthand. 3 means it's really strong in that area. 1 is, well, foundational, and 0 means it just doesn't apply.
Okay, cool. So let's kick things off. What is BionicChaos.com? What's the core idea? You mentioned making biomedical data processing accessible, but there's more to it, right? It has this distinct philosophy. It's open source, educational, and yeah, sometimes a bit chaotic in its approach, which sounds interesting. The idea is to lower the barrier for students, hobbyists. Anyone curious, really? Right. Tools right in the browser. No downloads, no installs. Just click and explore.
Exactly. The democratization is the core mission. But the key differentiator, I think, is that build-in-public philosophy. It's not aiming to be some perfectly polished commercial product right out of the gate. It's more about valuing the learning process itself, the journey.
You know, that chaotic build-in-public thing. At first I was like, does that just mean messy? But thinking about it for beginners, it kind of makes sense, doesn't it?
It does.
It highlights their main strength. Accessibility, that zero install browser native aspect is huge.
Yeah.
It makes really complex stuff feel, well, tangible for anyone.
Right. You just open a tab and boom, you're interacting with concepts that used to require labs or complex setups.
Okay, so that's the big picture philosophy. Now let's get into the specifics. How does this play out with their actual tools? Let's start with EEG brainwaves. These tools are designed to make abstract concepts like different brainwave frequencies visible and interactive. Right.
Precisely. And this is where Bionic Chaos really shines as an educational on-ramp. It's incredibly intuitive, frictionless. We scored its accessibility as Advanced 3. It's like a sandbox for brain activity concepts. You can play around, build intuition visually without any technical headache.
But there's always a trade-off, isn't there? It's designed for learning, so it's not a research tool. Our analysis found it lacks any real analytical power. It's not meant to be biophysically realistic either. It's illustrative. So its scores there are just basic 1 for analytical depth and basic 1 for biophysical realism. It shows you the shape, not the underlying science and detail.
Yeah, and that trade-off is super clear here. Intuitive learning versus deep research capability. So the verdict on the EEG tools, fantastic for foundational learning, getting that first grasp, but completely unsuitable for actual research analysis. Compare it to established academic tools like EG Lab or Brainstorm. They score Advanced 3 on analytical depth. They're built for research. Or for realistic simulation, you'd look at something like BISA Simulator, which gets an Advanced 3 for biophysical realism. Bionic Chaos isn't playing in that league, and that's okay. It has a different goal.
Okay, so from brainwaves, let's move to the heart. ECG simulation. The analysis described this as a basic tool for visual learning. And the ECG market is pretty wide, right? Everything from training games to serious diagnostic AI. Where does Bionic Chaos fit?
It sits right at the most basic introductory level. We called it a rudimentary toy, essentially. It's strength, simplicity, instant access to learning basic waveform shapes. Again, Advanced 3 for accessibility because it's just there in your browser.
Like a digital flashcard for heart rhythms.
Kind of, yeah. But beyond that initial visual recognition, it falls short pretty quickly.
Right. The weaknesses mentioned were lack of depth, not much use for actual clinical training, and low realism. And critically, the analysis stressed it has 0 clinical value. Scored 0 NA for clinical utility, and only basic 1 for pedagogical depth beyond just seeing the shape.
Definitely not something for diagnosis.
So don't use it to check your heart after a big meal.
Please don't. And it really highlights that question, who is this tool for? The verdict for the ECG tool is it's a functional educational toy, good for that very first look. But it's significantly inferior to dedicated training platforms or clinical tools. Think of SkillStat for clinical training games that gets an Advanced 3 for clinical utility. Or AI tools like PM Cardio, also advanced 3. Bionic Chaos isn't aiming for that at all.
Makes sense. Okay, next up, neuroimaging. The FNIRS and MRI viewers. FNIRS measures brain blood flow, MRI gives structural images. The analysis was very clear. These are viewers, tech demos, not analysis tools.
Exactly. Their strength is that frictionless viewing. No installs needed. Perfect for a quick classroom demo. That's advanced 3, accessibility again. They do a great job showing what can be done in a browser with these complex data types. Makes it seem less intimidating.
But the big limitation is they just view. They lack the functions needed for actual neuroimaging work, like motion correction, segmentation,
Yeah,
that sort of thing.
correct. Which means they only score basic 1 on analytical depth and basic 1 for specialized features. You can look, but you can't really work with the data.
It's like having a photo viewer versus having Photoshop.
That's a good analogy. It really comes back to setting expectations. What can this tool do? What can't? So the verdict, brilliant as an educational exhibit, a window into the data, but completely inadequate for anything beyond just looking. Compare that to powerful open source tools like Homer 3 for FNIRs or 3D Slicer for MRI, both advanced 3 for analysis, or high-end commercial software like Amira, also advanced 3, across the board, different worlds.
Okay, now for something that probably gets a lot of learners excited, machine learning. The neural network trainer uses TensorFlow.js, lets you play with neural networks visually, no coding required. That sounds pretty cool.
It is cool. We characterized it as an interactive tutorial. It does a fantastic job demystifying how neural networks train. It abstracts away the code into this simple graphical interface. It's a high-quality guide, not a development environment per se.
And it seems to really nail that educational goal. Strengths listed were learning training dynamics, clean interface, strong pedagogy, scored advanced 3 for ease of use and advanced 3 for conceptual clarity, like having a visual ML tutor.
Absolutely. You can tweak things, see what happens instantly, great for building intuition. The weakness, naturally, is that it is a simplified demonstration. The real heavy lifting power comes from the underlying TensorFlow.js library itself. So while it works for its purpose, we rated its computational power as intermediate too. It's not for massive, complex models. It teaches the how, not necessarily the high-performance what.
Right. So the verdict, best seen as a really top-notch interactive tutorial, captures that Bionic Chaos educational spirit perfectly. And comparing it, TensorFlow.js itself is powerful, advanced 3, computationally but hard to use directly, basic 1, ease of use. Whereas other great learning resources, like the Google ML course, also aim for that high ease of use and conceptual clarity, both scoring advanced 3. So Bionic Chaos is in good company there. Okay, so we've walked through the tools. Let's synthesize. What does this all mean for you, the listener, the student, the educator, the curious person?
Well, Bionic Chaos has carved out this really specific, valuable niche. It's not trying to beat research software. It is that crucial on-ramp. It builds intuition, gives you that hands-on feel without the usual setup pain. Our analysis suggests its future is really about doubling down on those educational strengths. So the guidance for users that came out of the analysis is pretty straightforward. Students, beginners, fantastic starting point. Build intuition, get comfortable, no tech barriers. Educators, it's a great free tool. Use it in lectures, make assignments more engaging, spark that initial interest. But researchers, clinicians, it might inspire ideas, but it's absolutely not for actual research, data analysis, or making clinical decisions. That distinction is vital.
Right, using the right tool for the job. And the analysis also had some suggestions for Bionic Chaos itself.
Yeah, a few strategic recommendations. First, really lean into that educational niche. More tutorials, more guided paths. Become the go-to first step. Second, formalize the meta-learning. That build in public thing is great. Maybe add developer logs. Teach the how of building these tools alongside the science.
Well, that's interesting, like teaching engineering craft too.
Exactly. And third, just enhance clarity. More prominent disclaimers. Educational use only. Manage expectations up front so people use it appropriately.
So wrapping up, BionicChaos.com isn't the whole destination, maybe, but it's a fantastic starting point, that on-ramp we keep mentioning. It makes complex things feel graspable, taking away that initial intimidation factor. It's about making abstract ideas tangible and, honestly, kind of fun to explore.
It really is. And that leaves us with a final thought for you to ponder. Given how well Bionic Chaos seems to work with this build-in-public, on-ramp approach for biomedical data, how could that same philosophy apply elsewhere? What other complex fields, maybe ones you're curious about, could benefit from lowering the barriers like this? Making knowledge more intuitive, more accessible right from the start. What else could be opened up?
Okay, so we got Gemini to review BionicChaos.com. Did a pretty decent job trashing it. Okay, what shall we do? Shall we pop it back into a review? We have another short review real quick. Let's do this one together.
Welcome to the Deep Dive. Today, we're really digging into some comparative data from BionicChaos.com. Our mission really is to pull out the key insights, see how their tools actually measure up against others out there.
Yeah, and it's a pretty broad look we're taking. We're covering Bionic Chaos in EEG simulation, ECG analysis, neuroimaging viewers, even their in-browser machine learning tools.
Yeah.
The idea is to figure out, what's the specific niche? What's the value compared to, say, academic toolboxes or research simulators or even clinical training software?
Exactly. What kind of user are we talking about here? And as we look through the data, one thing really jumped out. Almost across the board, Bionic Chaos gets rated advanced for accessibility. EEG, ECG, neuroimaging. It seems like user-friendliness is a top priority, making it easy to get started.
Right, but what's fascinating, and this connects directly, is the trade-off you see. High accessibility, yes, but often it scores basic on things like analytical depth. So it handles the fundamentals, but maybe not the super complex stuff, or biophysical realism, how closely it mimics the biology.
Okay, yeah, so less complex algorithms, perhaps.
Exactly. You contrast that with something like eGlab or Brainstorm for EEG analysis. They score on depth. I mean, they're powerhouse tools for researchers.
Yeah.
But their accessibility, often rated basic. There's a steeper learning curve there. Or BISA Sim, which is all about that high-fidelity biophysical realism. So it's a clear choice Bionic Chaos seems to be making.
That makes sense. And interestingly, we see that same pattern pop up again when we look at the ECG simulation data. Bionic Chaos, again, advanced for accessibility, super easy to jump into. But then it's marked NA, not applicable for clinical utility.
Not for actual diagnosis.
Right. And only basic for pedagogical depth, so maybe not the deepest teaching tool either, which really contrasts with, say, SkillStat. That one's also got advanced accessibility, but crucially, it hits advanced for clinical utility too. It's used for actual training, right?
Precisely. It's designed for that real-world scenario training. And if we sort of pull back and look at the bigger picture, the neuroimaging side, FNIRS, MRI tells a very similar story. Bionic Chaos, very accessible, gets you in the door, but then basic, again, for analytical depth and those specialized features.
So good for getting your feet wet, maybe.
I think that's a fair way to put it. It's like a great starting point, an on-ramp if you're new to FNIRS or MRI data viewing. You grasp the basics fast. But if you're doing serious research, needing complex analysis, multi-subject stats, detailed segmentation, you'll likely need to move on to platforms like 3D Slicer or Amira. Those offer advanced features, absolutely, but you're investing more time, definitely more effort into learning them.
Okay, so that pattern holds pretty strong. Accessibility often prioritized over, let's say, deep-in features.
Yeah.
But then we got to the in-browser machine learning section. And here, things looked a little different. What was your take on the Bionic Chaos trainer data?
Yeah, that was quite interesting, a bit of a curveball, because the trainer scores advanced not just for ease of use, which we'd expect by now, but also for conceptual clarity. And that's a really distinct advantage, especially when you're wrestling with tricky concepts, neural networks, data pipelines, that sort of thing.
Conceptual clarity.
Yeah.
How does that stack up?
Well, its raw computational power is rated intermediate. So it's not necessarily the fastest or most scalable for huge data sets, but it actually rivals the Google ML course, which also gets top marks for ease and clarity, but similar intermediate power. And it significantly beats something like TensorFlow.js in terms of ease of use and that conceptual clarity aspect.
Even though TensorFlow.js is arguably more powerful computationally.
Right. TensorFlow.js is incredibly powerful, no doubt, but it kind of assumes you already have a solid programming background and understand the core ML concepts pretty well. So it makes you wonder, doesn't it? What does power really mean when your main goal isn't just raw processing, but actually understanding something complex quickly, deeply?
That's a great point. So if we try to pull all these threads together, the main theme seems to be Bionic Chaos consistently goes for making complex tools incredibly easy to access, often maybe trading off some of the deepest analytical power or the most niche, specialized features to achieve that accessibility. But with a notable exception, perhaps, in their ML trainer, where they excel at making the concepts clear, which is its own kind of power.
Exactly. So, thinking about this, for you, the listener, what does it all mean? It really comes down to choices. Is your priority finding the absolute most powerful tool, the one with every possible feature, even if it takes weeks to learn? Or is it finding the tool that lets you grasp the fundamental ideas quickly, smoothly, with the least amount of friction getting in the way? Understanding these trade-offs, what you gain and what you give up with each choice, that's really key to navigating the landscape of digital tools today and making informed decisions.
Okay, so I want Gemini to do more on this. Want to find, can you find the hearing tools as well and compare them to other existing stuff? And let's do this 3. There's no audio available in Gemini. Sometimes there is, sometimes there isn't. I'll create a website out of it. Hey, can you actually indicate which tools, which exact tools were compared in each section? I'm not sure it's doing the correct thing. For each tool, can you actually include a working link? We have Phantom Cat projects joining in. Apologies if there's any delays in responding. Now Gemini is like hallucinating on me. Now I asked specifically for each tool mentioned on the page in the canvas, can we actually find the specific working link for that tool? If you can add all of them, that will be great. Yeah, we actually finished the LinkedIn stream. LinkedIn wasn't going anywhere. Pretty sure it's not promoting live streams whatsoever, so it's not showing them or something. I don't know what is it doing. Yeah, I'm pretty sure the YouTube algorithm does like the streams. So working for AI now, as pretty much everyone will be. Okay, the links are great, but you forgot the links to the Bionic Chaos website as well. So each tool that is mentioned, I need a working link. If you can provide it, that would be awesome. I think Phantom Cat does some vibe coding as well. Yeah, we're doing a lot of that kind of stuff. Okay, so we have the links. Sorry. Shall we turn it into a web page? Why not? We already have a version of it on this site. But yes, we're just diving into the detail. Essentially comparing our tools to other similar tools available out there. Should we pop that into Visual Studio Code? Okay, we have the tool in Gemini. It's kind of working, doesn't really fit. Okay, now it fits the screen. Mueller stuffed up the links. The links are not working. Okay, we need to fix the links. Some of the links are not working. Specifically, can you find the working tools on bionichaos.com? Okay, it's hallucinating links again. That's unfortunate. Okay, can we do a deep research on this? Start another canvas with the results. I need all the links to be correct, and we can cover all the separately. If we can cover all the different topics we cover on bionichaos.com. So have neurological EEG, neuro tools, cardiovascular, heart, ECG, PPG, ECG and PPG. Then we have biomedical imaging, vision, hearing, EMG. Can include EMG as another section. Comparing the EMG tools that we have to other existing tools out there. Yeah, it can include the simulation and modeling as another section. Data analysis. And the games as well, include games as a separate section. So you have to actually search bionichaos.com. Bionichaos.com, go check it out if you haven't done so already. Go over we got the thing and we're gonna do deep research on this thing again. Can do it again. And that might take some time.
Okay, let's unpack this. We are diving into the really fascinating world of cochlear implants today. We're using a description of an online simulator someone shared as our guide. Think of it as giving us a kind of keyhole view into how these, well, incredible devices process sound.
Exactly. That's the mission for this deep dive. We'll use the source material on this simulator to really try and grasp the core principles, how a cochlear implant actually works.
Seeing how those complex sound waves get translated.
Or maybe engineered is a better word.
Re-engineered, yeah. Into electrical signals the brain can hopefully interpret.
Right.
And that re-engineering aspect is so crucial, isn't it? It's not like a hearing aid just turning up the volume.
No, not at all. CIs are
I think we played that one in the past already. Pretty sure we did. If you have any questions, go for it. There is a human in the loop. Human in the loop. Human in the loop. Let's try a prompt engineer again. Okay, what's the agent is doing at the moment?
The agent is currently researching the BionicChaos.com website to understand its offerings in detail. It's looking at various aspects of the platform.
Oops, something went wrong. Yeah, everything in Gemini is like a prototype. There's a few options there. Let's Gemini send audio and video when speech is not detected. Okay. I'm just scrolling through a deep research of this agent. Can you summarize real quick what the agent is doing at the moment?
The agent is conducting a deep research project on bionicchaos.com. It's exploring the website for neurological tools, analyzing data, and gathering information about competitors for a comparative analysis.
Okay, we keep losing the prompt engineer. It's a bit unfortunate. Hey, what's the agent doing at the moment? Can you give a quick summary?
The agent is currently involved in deep research for the Bionic Chaos Biomedical Research Project. It's actively working on addressing inaccessible links, enhancing competitor analysis for EMG systems, and exploring various Bionic Chaos tools for comprehensive research.
Okay, what else are they doing?
It's also refining the Bionic Chaos tool access, ensuring links are accurate and accessible, and gathering more detailed competitor information from sources like Noroxon and Biopac. The next steps involve correcting links, collecting and synthesizing data, and preparing a final report.
And what the websites are mainly covered?
The agent is primarily researching web.
Yeah, keep going.
Okay, it's mainly researching.
Yeah. Our prompt engineer is getting stuck. Can you keep going?
It's primarily researching websites related to Bionic Chaos and competitor systems like those from Noroxon and Biopac. It's also exploring various biomedical tools and data analysis techniques across multiple websites.
Okay, and can you summarize its thinking process? I'll scroll down as well. Can you go over what is it doing currently?
The agent's thinking process involves systematically identifying and verifying links, gathering competitor information, and categorizing the various Bionic Chaos tools. It's focusing on comparative analysis, refining research methods, and preparing to structure the gathered information for a comprehensive report.
Okay, what else are they doing?
It's also expanding its exploration of Bionic Chaos tools, covering simulation, modeling, and gaming sections. The agent is aiming to synthesize all collected data into a structured report, outlining key findings for each section.
What's the agent currently doing? What's the progress? And what is it researching into?
The agent is currently researching 133 websites to gather information for your deep research request. It's focusing on BioChaos tool exploration and deepening EMG competitor analysis. The next steps involve finalizing data collection and report structuring.
Yeah, we keep losing the prompt engineer. That's not fun. Hey, can you browse the web and tell me what are the ways that I can talk to a Gemini voice model while sharing my screen? Or is it only available on the phone? I would like to do it on desktop through the browser. Is it possible? I don't know why all these things are available on mobile. Limited rollout phase. Well, why is it available on the mobile? Yeah, the AI Studio used to work much better. Okay, what's the agent currently doing?
The agent is currently analyzing the results from the deep research request. It's summarizing the gathered information right now.
Hey, can you be more specific?
It's currently pinpointing specific details regarding the Norexon and Biopac EMG systems, and will then synthesize this information into a comprehensive report covering various aspects, like biosensing tools and data analysis.
And can you summarize the research, the deep research request, the original request?
The original deep research request focused on understanding the Bionic Chaos platform, investigating various biosensing technologies, comparing EMG systems, and analyzing the company's capabilities in simulation and modeling, as well as their involvement in data analysis for gaming.
Okay, and what's the agent doing at the moment?
The agent is still analyzing the results from the deep research. It's working to synthesize the information and structure the final report.
And what websites does it look at?
It has researched various websites, including Bionic Chaos, YouTube, OpenFS, Natus, and several other medical and research sites related to biofeedback technologies and EMG systems.
Okay, what's the agent doing at the moment?
The agent is currently focusing on consolidating the information it has gathered and structuring the final report. It's synthesizing the key findings from the deep research.
Can you be more specific? Don't be shy.
It's focusing on organizing the information into detailed sections, including an introduction to Bionic Chaos, its biosensing tools categorized by neurological, cardiovascular, biomedical imaging, vision and hearing, and EMG, as well as simulation and modeling capabilities, along with the comparative analysis. It aims to include a summary of strengths, weaknesses, and future directions.
Yeah, it's actually seemed to be working with this specific settings. Yes, we're using Gemini. Unfortunately, in AI Studio, because that's the one we can share screen with. Well, they have gazillion of voices. Tried only some of them. Not sure if changing the number of tokens per image changes anything or not. It doesn't seem to make much difference. Now I'm noticing that turning coverage and effective dialogue actually reduces the chance of the call dropping. So turning coverage is it lets Gemini send audio and video when speech is not detected. Okay, fine. So would it then be looking at the screen changing? And then effective dialogue is letting Gemini adapt its response style. Okay, fine. So it seemed to work well. Let's try a different voice. And we're still waiting for the report. Hey, can you review what's on the screen real quick?
Sure. What specifically on the screen would you like me to review? I see a comparative feature score chart related to EEG simulation.
Okay, so what's this page is all about?
This page is a critical analysis of BionicChaos.com, focusing on web-based biomedical data processing tools. It includes a comparison of EEG simulation tools.
Okay, keep going. What's on the screen?
It discusses the Bionic Chaos philosophy, emphasizing its core mission, key differentiator, and primary strength regarding biomedical data processing tools. It also details the EEG simulation and visualization features.
Okay, and what's happening now on the screen?
The screen is showing the EEG simulation and visualization section, displaying a comparative feature score chart that compares different EEG simulation tools. It highlights their accessibility, analytical depth, and biophysical realism.
Okay, and what's Bionic Chaos scores like?
Bionic Chaos shows an advanced level of accessibility, but basic levels for both analytical depth and biophysical realism.
Okay, how about the other tools? Do we actually know what they are?
EEG Lab has advanced.
Yeah, keep going.
analytical depth,
I'm getting stuck a bit. Can you go again?
Sure. Focusing on EEG lab, it has advanced analytical depth, basic accessibility, and intermediate biophysical realism.
Okay, how about the brainstorm?
Brainstorm has advanced analytical depth, basic accessibility, and intermediate biophysical realism.
And how about the last one, best sim? And also, if you know what they are, do let me know.
BISA-SIM has intermediate accessibility, basic analytical depth, and advanced biophysical realism. These tools are used for EEG simulation and visualization.
Okay, how about the ECG comparison? Can you just give me all the details at once?
For the ECG comparison, Bionic Chaos has advanced accessibility, basic pedagogical depth, and basic clinical utility. ECG SIM has intermediate accessibility, intermediate pedagogical depth, and basic clinical utility. SkillStat has advanced accessibility, intermediate pedagogical depth, and advanced clinical utility. PM Cardio has intermediate accessibility, basic pedagogical depth, and advanced clinical utility. It seems like Bionic Chaos doesn't have a specific metric for clinical utility in the comparison chart, unlike the other tools, which have scores for accessibility, pedagogical depth, and clinical utility. It might be because it focuses more on the educational aspects rather than direct clinical use. Looking at the chart, it seems like SkillStat and PM Cardio have the highest clinical utility scores. Also, Bionic Chaos has the highest accessibility score, while ECG Sim has the lowest accessibility. SkillStat also appears to have the highest pedagogical depth. Is there anything specific you'd like to know about these points? Sure. I can go over the neuroimaging section with you again. It looks like Bionic Chaos and 3D Slicer have the highest accessibility, while Homer 3 and Amira have the highest analytical depth. 3D Slicer also has the highest specialized features. Is there anything particular you want to focus on regarding these tools? Okay, the interactive demo is started. Different modalities are appearing on the graph, one at a time. Each one shows its temporal and spatial resolution, along with the cost and some applications. It's like comparing different ways to measure things. All right, the demo is continuing. More modalities are being displayed on the graph, each with its own temporal and spatial resolution and cost information. It shows a variety of options for different applications. The demo is still running, and more modalities are being added to the graph. You can see how they vary in terms of temporal and spatial resolution and cost. The information for each one is displayed on the pop-up. Sure, I'll continue monitoring the demo. The graph is being populated with more modalities, and for each one, you can see its temporal and spatial resolution ratings, the cost rating, and the typical applications. It provides a comprehensive overview of different sensing methods. All right, the demo has completed presenting all the modalities. It showed a variety of sensing techniques, each with their own temporal and spatial resolutions and cost ratings, along with their typical applications. The upper panel provided a summary statistics like the total number of modalities and the average ratings. This tool seems helpful for comparing and selecting different sensing methods.
Okay, the AI studio is playing up. So, yeah, I'll have to try it another time. Yeah, essentially, go check out bionicchaos.com if you haven't done so already. There should be links everywhere under the sun. These are the topics we cover. Go check it out. For saying hi, whoever did. But if you could also go check the website and provide your feedback, that would be amazing, especially if you are a human. But AI robots are welcome as well. We do not discriminate. Well, not on this channel. You got ECG simulators, synthetic noise generators, advanced EEG signal simulators, a cochlear implant, obviously. Pretty sure I played that audio before. Should be somewhere on YouTube. FNIRS. Can scroll, play. In this modalities demo, we did a notebook LM audio before, and this one. This one we did yesterday or something. Let's stop the demo. Ooh, what's up? Okay, now it's actually working. Yeah, there's loud noises, stuff going on. I'm doing deep research on this kind of stuff, essentially comparing the tools we have to other stuff available online. Actually, let's play this real quick and we'll finish on that one, on that note.
Okay, so let's unpack this. Imagine you're faced with like a huge amount of really complex biomedical data research papers, dense articles, tricky concepts. What if there was a way, maybe a shortcut, to actually get your head around it all, something designed just for you, the learner?
That's exactly what we're diving into today. There's this unique platform, bionichaos.com, and it's basically an open source, web-based platform. Its whole goal is making this incredibly complex biomedical stuff accessible, understandable for anyone, really, no matter your background.
Yeah, and what's really striking, I think, is that this isn't some giant corporation behind it. Bionic Chaos is, well, it's the work of one person, a founder and developer, Yuri Benno, driven by this mission to democratize biomedical data processing.
Right.
Think of it like your personal guide through the chaos of biomedical data, as the name suggests. So our mission today is to pull out the key insights from this resource, focusing on how it helps you learn, how it helps you think like a scientist.
Exactly. And its real strength, I'd say, is in its teaching method, its pedagogy. It uses these interactive apps right in your browser, no installation needed, which is great. And they effectively break down really tough topics, things like EEG, electroencephalography, brain waves, or ECG, electrocardiography, which is heart signals, even complex things like neuroprosthetics.
Okay, so interactive is good, but you mentioned gamification earlier. That sounds interesting, but you know, for serious stuff like ECG analysis, isn't there a risk it just becomes too simple, like a game?
That's a fair question, definitely. But Bionic Chaos seems to handle it really well. It builds serious learning into the games. So take CardioQuest, for example. It's for ECG training. You're basically clicking on abnormal heart rhythm bits you see on screen.
Okay.
And the faster you get, the higher your score, the quicker it moves. It really sharpens your pattern recognition skills.
Ah, I see. So it's not just clicking buttons.
No, not at all. And then there's another one, Cardiobot. It's more advanced. You're actually competing against an AI, identifying ECG patterns in real time. It's pretty novel and honestly quite effective for building those critical skills.
Competing against an AI, wow.
Yeah. You get instant feedback, that competitive element. It makes learning something pretty complex feel, well, less like homework and more like mastering a skill, you know?
That makes sense. Okay, so it handles heart signals well. What about the brain stuff, the neurological data?
Oh yeah, the Neuro toolkit is surprisingly deep. There's an advanced EEG signal simulator. You can actually tweak parameters, see how delta, theta, alpha, beta, gamma waves mix together. You could even simulate patterns like deep sleep or seizure activity right there.
Simulate seizures. That's pretty powerful for understanding. And what about those really cutting-edge topics like brain-computer interfaces, BCIs? How does it tackle those? Just explain them.
This is where it gets really interesting for developing critical thinking. It doesn't just explain, it offers these rigorous, almost academic-style critiques. Take its analysis of the stentrode neuroprosthetic.
Okay, the stentrode.
It doesn't just tell you what the tech is, it actually critiques the research paper itself. It points out potential issues, like small sample sizes in the study or possible conflicts of interest.
Wow. Okay, so it's teaching you how to read between the lines of scientific papers, too.
Exactly. It equips you, the learner, with the tools to analyze scientific claims critically, to become a more discerning reader.
That's incredibly valuable.
And connecting this to the bigger picture, there are other tools, too, like the EMG hand simulation tool. They call it EM gesture. You click on a finger on a diagram of a hand, and it simulates the movement, but also generates the EMG signal, the bioelectrical signal that goes with it. It creates this fantastic visual link between, the physical action and the electrical signature.
That visual link sounds key.
It really is.
Yeah.
And this points to Bionic Chaos' specific niche. It's not trying to be a super high-end clinical system. It's more like a conceptual sandbox, an educational on-ramp, zero cost, zero setup. You get to grasp the fundamental ideas before you ever touch expensive professional gear.
Which makes you wonder, how does a lean open source project manage all this breadth and depth? It's impressive.
It really is. It speaks volumes about the focused vision behind it.
And it's important we stress this point again because it is educational and experimental platform. These tools are absolutely not for clinical diagnosis or commercial use. It keeps that focus purely on learning.
Right. Absolutely crucial distinction. So what's the takeaway for you, the learner? Bionic Chaos is, well, it's a really significant contribution to open science and education. Commendable, really. It genuinely lowers that barrier to entry for understanding complex biomedical data. It uses interactive, accessible tech in a very modern way.
Yeah, it's a powerful example of what a single focused vision can achieve with open source principles. It's more than just data presentation, it's like a playground for understanding.
It really is. And it makes you think, doesn't it? What other fields, traditionally seen as really complex or specialized, could benefit from this kind of approach? This accessible, interactive, even gamified pre-lab sort of exploration, it kind of changes how you might think about learning tough subjects.
Yeah, go check out the site. Like, subscribe, you know what to do. Unsubscribe, whatever you need to do. And I'll see you next time. Bring your questions. Check out the site and bring your feedback. Bye.